Tough the day after the big party, always. How's everyone doing? Excellent. So, goal here is to give you some context and a view into software-defined networking and really things that have evolved. And it's like the thing that everyone's talking about, the software-defined network. So I want to put that in the context of the actual network itself. And we look at what's happened over the years. It's been fascinating to see the transformations that have taken place in the carrier market, whether you're a mobile operator, wireline, cable operator, the changes have been dramatic. And what's interesting about these changes and how we've moved at lightning speed to newer technologies, the fundamental network hasn't changed in many, many years. Now, it's been a journey from a carrier perspective to get to that IP network. At this point, we're finally at a point of all IP. And that was a monumental evolution that took place, driven by generational technologies. As we moved into 3G and 4G networks, we started to see the IP transformation taking place, and I think predominantly we're looking at an all IP environment. But things like disaggregation, talking about things like SDN or software-defined networking, network function virtualization, virtualized network functions themselves, and ultimately getting to the virtualization of the network is still a journey that's underway. How we get to that next generation of networking technology is really the challenge. Certainly things like disaggregation make a lot of sense, but really I think we're at a point in which the network truly becomes the service platform. And for a long time, we've talked about the network being the platform, and the network enabling services and integrating services. But I think we're at a point with where technology has evolved that the network itself can fundamentally start to deliver these capabilities. At the end of the day, the network matters. Everyone that is speaking talks about the network. Now, in the context of the carrier environment, the network is very broad and reaches into a number of technologies. How we leverage the network to deliver services, the notion of the network from a mobile operator perspective is very, very broad. But the fundamental network itself matters. It's what fuels and creates the capabilities, the bandwidth, and the functionality that we're delivering to our subscribers. Disaggregation is fundamental and in some ways where most things are going. Some carriers are just beginning in that journey. Others are much farther along. So white box hardware, taking advantage of merchant silicon, or some people use the notion of the commoditization of the hardware side. Look, technology is advanced to a certain point that the fundamental hardware delivers the functionality we need to be able to deliver services, to deliver the bandwidth and the reliability that's required. We've been able to reduce costs. Cost per bit and reducing overall operating costs is a major, major driver here. But certainly when we think about the economics of white box technology, it becomes very, very compelling to change the operation. But the challenge when we think about white box technology and leveraging that within the network environment is not everything is equal. A lot of conversation in the past day here talking about things from open source. It was an excellent panel on day one. If open source is really ready for production-based environments, and that's the challenge. Most operating system environments are enterprise class. We're still at a fundamental early stage of getting to this notion of disaggregation. The market is still driven by a handful of core networking vendors that are delivering traditional network architectures. So as we move and think about white box technology and how we start to master that, we have to think about how the network is built and the changes in the fundamental network environment. So we talk a lot about SDN and NFV and VNF, but at the end of the day, the network hasn't fundamentally changed. How we build that network with horizontally integrated systems, closed architectures, hasn't changed. So along comes SDN, and SDN gets broadened from a conversational perspective in this event to mean lots of things. And certainly things like automation, and we'll talk about that, are part of the notion of software-defined everything, but we move to the generation or the initial generation of software-defined networking. Why hasn't that been widely adopted? We talk about controlling and running everything from a software-defined perspective. Then next generation software-defined networking comes along and changes things in a very significant way. See, the challenge with the first generation of SDN is we took fundamental principles of separating things like the control plane and the data plane to be able to create an environment that you can control and program. If you've been around networking for a long time and you look at this picture of a traditional SDN network, it's fundamentally a chassis. If you put a chassis, and it doesn't matter which vendor, they have line cards and a backplane and supervisors, we've just blown that up into individual boxes. And while it really has been the driver for first generation of software-defined networking, it's complicated. It really limits how you deploy SDN. Because of that controller relationship, the controller runs everything. It controls all of the devices that are within the network. It requires you to change all of the components in the network to be able to communicate with that controller. Now, controllers make sense in running the broader network environment, the broader service environment, because now I can use controllers to integrate the compute side, the storage side, and drive broader orchestration across my technology stack. But having controllers control controllers doesn't make a lot of sense. So that's been the obstacle. The second challenge with first generation SDN is their closed systems. Generally speaking, the SDN systems that are coming from the large vendors are still non-white box based. So you're not able to take advantage of the efficiencies that you're looking for. So SDN has been too complicated, and probably more adoption of SDN technology within the carrier segment than the enterprise. We've seen very use case specific deployments of SDN on the enterprise side where people are using it as a packet broker and other types of things where the complexity doesn't matter. But that's been the primary obstacle, and so changing that dynamic is critical. Moving to a next generation of SDN where we're able to disaggregate not only the hardware and the software component, but where we can start to change the architecture of how we actually build that network. Next generation SDN takes full advantage of disaggregation. It's 100% white box based. Your traditional SDN or first generation SDN, the majority of deployments is not. So when you think about next generation SDN, you're going into this environment where white box is the driver, white box is the enabler. And the technology from a white box perspective, I don't need to drive the benefits, is there to deliver the power and the performance and the capabilities to integrate all these services. The big difference between next generation SDN is the elimination of the controller, how we build the network differently to distribute control and functionality across the network. So that controller is the limiting factor in most SDN deployments. It limits convergence or slows convergence. It limits distribution, which all carrier networks are widely distributed. So the goal here is to look now at how I can transform different services and transform building the network by leveraging this next generation SDN technology. First, you really move away from vendor lock-in, and that's always an interesting topic I love to debate because there's no such thing as no vendor lock-in. You're going to choose a vendor, it's going to become part of your primary mode of operations, and you're going to stay with that vendor. But it allows you to start that disaggregation model and mix hardware vendors within your networks. Get the right box to do the services and the performance and the capabilities that you need to be able to run. Create that interworking and interoperability environment so you don't have to replace everything. That's fundamentally the way that you start looking at changing the economics. And with white box technology, you can build out a very large network with very simple fixed configuration boxes. And you can build that network architecture to scale to support that environment, just like you can with the first generation of legacy networking. Right? We need to build very large networks to support the technologies that we're deploying. And you think, well, going to white box, going to SDN is going to limit my ability to drive these larger environments. What you get with today's white box technology is this ability to scale out in a much more elastic, dynamic way and deliver predictability of performance, predictability of latency, which are all critical in delivering services today. The second aspect to think about when we talk about disaggregation is automation. And that's a big topic here as well. Automation is the key driver of how we evolve our operational models. The problem is disaggregation doesn't always mean automation. Yeah, we're disaggregating the box from the software, but we're still running the network the same way. SDN is what changes that environment. And so I can front end that, I can put an automation platform in there, but it's still going out and communicating box by box and telling those different devices what to do. Whether it's using scripting or APIs, it's still a very, very significant process. There's still room for errors. There's still operational risk within that model. When you look at next generation SDN, it becomes much more integrated from an automation perspective. I like to call it automation from within. Because you're building a fabric architecture, it's a lot different than relying on individual boxes. If I use a controller in first generation SDN, that's my management point, but it still has to communicate with all the devices in the network environment. With next generation SDN, you're actually building an environment that's federated, that's basically peer-to-peer type of environment, and so they're all sharing the knowledge and state across the operating environment. In this case, your integration is through one point, one and any point within the network to be able to create those changes in programmability, and that ensures consistency across the network and reduces your time to configuration. Another aspect of software-defined networking, and this is something that I think really changes the dynamic of how we're able to build services into the network, is actually virtualization of the network. So how do you get your head around this concept? Think of VMware. I put VMware on a bare metal server. I segregate that server into virtual machines. And in each of those machines, I'm running a different application. The same thing is being done on bare metal switches. Microsoft uses this fundamental concept within their data center environment as well, creating separate network entities and network services within this white box technology gives you a tremendous amount of flexibility. Because I've got clear segmentation. We call it in the carrier space network slicing. And network slicing is done in a number of different ways. And in mobile networks, network slicing is done at a spectrum level and broader in the service creation part. Here it's fundamentally done at the network. Actually create containers within the network environment that are independent and separate from each other. Think of it this way. I can create a distributed network environment with distributed resources. You're fundamentally taking a shared set of infrastructure and slicing it up, completely separating it from one another. I mean, for those of you technical, its own control plane, its own router, its own functional entity, but they're running on a common infrastructure. I can now deliver services differently. I can do true network function virtualization. I can integrate into this environment in this slice a firewall function, a load balancing function from any vendor running within the network itself and being applied to specific uses. This is how you tenant or segment the network in a much more modern way, different than using VLANs. Because the challenge with VLANs in a multi-tenant environment is now I have to remap everything to accommodate the customer's VLANs. In this environment, you're creating hundreds of individual networks that's sharing common infrastructure. And I can distribute that on a global basis across the national network to be able to deliver those services to the customer. Now think about how I start applying that to the notion of network slicing beyond just what we're really thinking of in 5G. This starts to make sense in the broad spectrum of services that we deliver from the production environment. Being able to deal with and isolate and apply security for things like IoT, to be able to deal with interconnect within the colo or the POP environment for subscribers, being able to segregate those services as well as how we deliver it into the 5G environment. As I look at modernizing the central office and delivering NFV services across multiple COs, that becomes a critical factor. As you virtualize the network, as you slice the network, you can start to integrate services into the network in a completely different way. VNF and NFV have certain meanings, but really truly being able to bring these capabilities and run them in the network itself helps you drive a broader range of services in a more effective way, in a much higher service velocity in how you're able to deliver these services to your customers. And because you're dealing with the next generation of software-defined networking, you eliminate this dependency on the controller interaction. You've built an environment that's virtualized, that understands it's a distributed environment, so now you can interconnect your services geographically. See, in first generation SDN, I've got to put controllers in each location and then use standard internetworking to connect the locations. That's really not SDN. There's still separate networks that are tied back together. In this environment, I'm able to build a geographically distributed environment and run it as one large network, even though it's completely distributed. This allows you to take the slicing or segmentation or tenant services, whatever language you want to use, the virtualization of services, all these capabilities, and stretch it across the network. Stretch services, stretch resources, pool resources. I have the ability to take resources from data center 4 and apply them to data center 2 when I hit resource exhaustion, when I have an outage, high availability and resiliency capabilities. Think of interconnection, cross-connect for direct connect services to subscribers. I won't say the carrier because they're doing a great job, the vendor. I should say the operator. But I remember a conversation with an operator who was very proud to say, we have got it down. We can cross-connect and bring up a new customer in our colo, in our environment, in 2.5 days. Operationally, we've got it nailed. But that's a manual process. By leveraging the whole notion of tenantization, by the notion of SDN and where you can go with white box technology, you can actually build an automated cross-connect environment today that would reduce that to minutes. Because you fundamentally have the infrastructure in place, you have the ability to slice the network to support these different services, and with the next generation of white box technology and what you can do with Broadcom Silicon, for example, you can deliver true layer 1 interconnectivity with true pass-through at a substantially lower cost than the traditional way of doing it with optical interconnect systems. You're going to get not only higher density, you got up to 100 and plus 10 gigabit ports per rack unit in today's white box technology, even more. And then being able to actually get the cost down becomes very, very compelling. So thinking of this technology not only in the production environment, but supporting and accelerating cross-connect can really change the operational model. And the same thing goes in the lab environment, which is fundamentally the same principles as cross-connect. Every carrier, every operator is running labs. They're running legacy interconnect systems in these big, huge fiber, optical, backplane-based environments. You can leverage white box technology to do that for half the cost or less and get the density increased and being able to support the latest generation speed. See, the problem with most of these older technologies is you've got very low density, 1 gig and 10 gig, and struggle to get to 25, 40, 100 gig interconnects. You can do that with white box technology in a very, very efficient way. So it gives you this ability, and by the way, in that environment, it emulates a production environment. It looks just like your production network. So you're able to get more real-world testing and be able to emulate what's actually happening in production. And because you're segmenting the network, you can run half your production and half your lab within the same infrastructure itself. So SDN becomes a true network transformation enabler and allows you to really master and harness the power of white box technology. It really becomes a carrier class operating environment that lets you slice, lets you automate, and change the way in which you build the network. Taking advantage of white box economics, which is going to reduce costs, but fundamentally change the way you deliver services and do that. I mean, think of it in two contexts. It's always fundamentally the same. Improve from an operational perspective, and how do you drive more services and create more revenue and lower the cost per bit from a technology perspective. Certainly that's what we're all driving towards from an operational perspective, and when we're building this network, it's all about what we enable, right? I'll put it in context for Pluribus Networks, and we're probably the company that no one knows because we've actually built a lot of these networks, but from a background perspective. And I'll give you a sense of why I say that in the next slide. We actually have 15 plus production operating environments in large networks. Mobile operators running EPC, running traffic across those networks, VoLTE traffic, signaling traffic in real networks. We have 20 plus active field interoperability trials that are running today with cutover this summer into live production environments. We do have a range of deployments, and again, I'll show you in the next slide a context of one of our early wins that really has driven our development and our technology, but we're in a number of different deployments from point-to-point, point-to-multi-point hosting, interconnection environments within carriers, sitting in the next generation EPC, the virtualized EPC environment for mobile networks, NFV pods. What really built the basis of Pluribus as the company was founded was we were originally OEM by Ericsson to leverage for their cloud system as the operating environment, the fundamental network that runs it, as well as on the enterprise side, but it's actually deployed in a lot of carrier environments, the TIBCO enterprise messaging platform. And so that's great. It's a good proof point that shows that we're in real networks in very mission critical, high volume, high transaction volume environments. But the bigger message there is they drove the development of this operating environment. They defined and demanded the features and functions and scale and resiliency that's being delivered in the product today as we then extend out and work with carriers directly and in the enterprise space. So that's been a really significant factor in driving the product forward. In the Ericsson environment, if you're familiar with their HDS 8000, we are the fundamental network that runs that environment. We are the base SDN fabric that crosses multiple MSCs, multiple switching environments, provides the interconnect across that, provides the virtualization to do the network slicing that they talk about, and to do all that fundamental capability. It's the same kind of model for TIBCO. The difference is in the TIBCO model, we're actually running the application in our switches. We've truly virtualized the application, and it's running in the switch infrastructure to speed up transaction processing. And there's been coverage, Light Readings had coverage and other things. We can't talk about the carriers that we're deployed in, and so in respect for that, but there's definitely stuff out there. I hope it was useful. Really appreciate the opportunity to give you insight into where SDN is going, and have a great rest of the show. Thanks, everyone.
Steve, thank you very much.
Thank you.
Just a very quick question, if I can grab that. Next generation SDN, or FFA, not sure I can bring myself at FFA, another three-letter acronym, but is the industry, I mean, SDN was difficult first time round, it's been very complex. Is the industry ready? Is there pent-up demand, do you think, for this next generation SDN?
I think there is, right? I think people want to break the traditional vendor model and move the network to an easier way to manage and roll out services. The problem is the complexity has been the obstacle. Of all the customers I've talked to, it's just too complex. And so looking for a better way to do it, and certainly breaking the vendor lock-in model, I think they are. I think we're definitely seeing more and more adoption of this technology.
Okay, excellent. Steve, thank you very much.
Thank you so much.
Thank you.
Thank you all.